20 miles southeast of a Japanese convoy in the East China Sea, Lieutenant Commander James Patterson held his PB-4Y2 privateer steady at 15,000 feet on that late April day in 1945. The 28th of the month, to be exact. Inside the aircraft, his radar operator watched 4 glowing blips move across the cathode ray screen, small points of light that represented vessels crewed by men Patterson would never lay eyes on. The ships themselves remained invisible beyond the horizon, nothing more than electronic signatures in the darkness of distance. Suspended in the bomb bay below Patterson's seat hung 2 weapons that would have seemed like pure science fiction just a few years earlier. ASM-N-2 BAT guided missiles that possessed a kind of primitive intelligence, an ability to see and think and guide themselves toward death without human hands steering them to impact. The radar operator's voice cut through the engine noise with bearing and range information, 45 degrees off the bow, 18 miles distant. These few words represented the only acknowledgement that real human beings sailed those distant vessels, men with families and fears and futures that were about to be cut short by weapons they couldn't possibly understand. Patterson would release his missiles and they would fly themselves to target while his crew banked away toward safety, heading home before the enemy even realized death was approaching from the sky. This wasn't warfare as it had been practiced for thousands of years, where courage and skill and the ability to look your enemy in the eye determined victory. This was something new and unsettling. Warfare transformed by American industrial might into a mathematical equation where thinking weapons removed human agency from the act of killing itself. The BAT missile represented humanity's first stumbling steps into what would become the modern age of smart weapons and unmanned combat, a primitive ancestor to the precision-guided munitions and drone strikes that would define warfare in the decades to come. What made the ASM-N-2 BAT so revolutionary wasn't just its technology, though that was impressive enough for the era, but what it represented philosophically about how wars would be fought in the future. The missile was the world's first fully autonomous guided weapon to see actual combat use, developed by brilliant minds at the National Bureau of Standards under the direction of Dr. Hugh L. Dryden, a man who would later help launch America into the space age as NASA's first deputy director. Unlike the radio-controlled glide bombs the Germans had developed, weapons that required a human operator to guide them all the way to impact, the BAT was genuinely fire-and-forget technology. Once released, it used its own radar eyes to find targets and adjust its flight path without any human intervention whatsoever. The technical specifications of this weapon were remarkable for an era when computers filled entire rooms and the transistor hadn't yet been invented. The missile weighed in at 1,880 pounds, with a wingspan stretching 10 feet from tip to tip, carrying a 1,000-pound ANM-65 warhead packed with high explosives. Its S-band radar seeker could detect large ships at ranges up to 20 miles when conditions were favourable, though that performance degraded quickly in bad weather or when searching near coastlines. The guidance system relied on analog computing technology, vacuum tubes, and servo motors working together to continuously adjust the flight control surfaces, maintaining a glide path that would intersect with the target. It was crude by modern standards, but absolutely cutting-edge for 1945. The story of how this weapon came to exist begins back in January 1942, when the US Navy's Bureau of Ordnance recognized they had a serious problem that needed solving. Anti-aircraft defenses were getting better and better, making it increasingly dangerous for bombers to get close enough to their targets to drop conventional bombs accurately. What they needed was a standoff weapon, something that could be released from outside the range of enemy guns and still find its way to the target. The National Bureau of Standards assembled a team of the best minds they could find, pulling in aerodynamicists, electronics engineers from Bell Labs, and physicists from universities all across the country. By March of 1943, barely 15 months after the project began, they were testing prototypes at Naval Air Station Patuxent River in Maryland. What truly set the BAT apart from other weapons programs wasn't just the technology itself, but America's unique ability to mass-produce complex equipment. While Germany struggled to hand-build small quantities of their guided weapons, each one almost a custom creation, American industry cranked out approximately 3,000 Bat missiles using standardized production methods. Of those, only about 420 would actually see operational deployment before the war ended, but the capability to produce them in quantity existed. The entire program cost $12 million in 1940s money, which translates to roughly $180 million in today's currency, yet that represented less than 0.1% of total American military production. The country could afford to spend that kind of money developing a weapon that might not even work, just to see if the concept had merit. The Bat missile's first taste of combat came on April 23, 1945, when Squadron VPB-109 attacked Japanese vessels anchored in Balikpapan Harbour on the island of Borneo. The mission didn't exactly go according to plan. Both missiles fired that day failed due to technical defects, a harsh reminder that even revolutionary technology faces problems when it first enters service. But the engineers analysed what went wrong, made corrections, and sent the crews back out. Just 5 days later, on April 28th, VPB-109 achieved what the history books would record as the Bat's first confirmed kill. A Japanese patrol vessel in Balikpapan Harbour exploded and sank after being struck by a missile that had travelled approximately 9 miles from release point to impact. The American aircraft that launched the weapon was already turning for home when the explosion occurred, its crew unable to see the result of their attack. For the Japanese sailors aboard that doomed vessel, death arrived from an empty sky with no warning, no engine noise, no visible enemy aircraft diving toward them. One moment they were at their stations, the next moment 1,000 pounds of high explosives detonated against their hull. The psychological impact of these attacks far exceeded the physical destruction they caused. Japanese naval personnel had absolutely no framework for understanding what was happening to them. Everything in their training emphasized visual combat, ship-to-ship engagements, where you could see your enemy, anti-aircraft defense against diving planes you could track with your eyes and shoot at with your guns. The very concept of a bomb that could see with radar and think with electronics, adjusting its own flight path to home in on its target, was simply outside the bounds of their comprehension. It was like black magic, technology so advanced it might as well have been supernatural. To really understand just how significant the Bat missile was, you have to grasp the enormous technological gap that existed between American and Japanese capabilities by 1945. Japan had entered the war with some genuinely excellent weapons and well-trained personnel. Their Type 93 Long-Lance torpedo was arguably the best in the world, with greater range and more powerful warhead than anything the Americans had. Their naval aviators were skilled and experienced, their night fighting techniques superior to what the US Navy could manage in the early years of the war. But while Japan focused on refining and perfecting existing technologies, America was busy inventing entirely new categories of weapons that operated on principles Japan couldn't even conceptualize. The Bat incorporated miniaturized radar technology, analog computing, gyroscopic stabilization systems, and automated control mechanisms, all working together as an integrated system. Japanese engineers who got their hands on captured American radar equipment could identify individual components, could see the vacuum tubes and wiring and mechanical parts, but they couldn't grasp how these pieces worked together as a coherent whole. The disparity went deeper than just technology, extending to fundamental industrial philosophy. American production emphasized standardization and mass manufacturing, with every Bat missile built using interchangeable parts manufactured to precise specifications. Japanese production remained largely artisanal, with skilled craftsmen building weapons almost one at a time, each slightly different from the last. The combat record of the Bat missile was modest but meaningful in its implications. On May 1, 1945, VPB-109 sank a second small vessel off the coast of Borneo, likely a patrol boat or coastal craft. The squadron's war diary recorded the attack in dry official language that couldn't begin to convey what it meant to the men who died when that missile found its mark. A week later, the squadron achieved what might have been its most impressive success, striking the Japanese escort vessel Aguni. The missile hit the ship but didn't manage to sink it outright. Aguni survived with heavy damage, limping back to port for repairs that would never be completed before the war ended. While not technically a sinking, this attack on a proper warship, rather than a small patrol craft, demonstrated the weapon's potential against defended targets that could shoot back. On June 18, 1945, VPB-109 achieved its final confirmed kill of the war, sinking another small patrol vessel. Additionally, the squadron managed to destroy at least one oil storage tank on land, proving the bat could engage stationary targets as effectively as moving ships. These three confirmed sinkings, all of relatively small vessels, might seem disappointing compared to the thousands of ships sent to the bottom by conventional attacks during the war. However, they represented something far more significant than their immediate tactical impact. They were proof of concept that warfare could be conducted by machines acting independently of direct human control, that the age of automated killing had arrived. The other squadrons equipped with bat missiles, VPB-123 and VPB-124, achieved no confirmed successes whatsoever. Their after-action reports paint a picture of numerous technical problems plaguing the weapon system. Radar seekers got confused by land masses, locking onto islands instead of ships. Humidity damaged sensitive electronics. Distinguishing targets in congested waters proved difficult, with the primitive radar unable to tell a warship from a fishing boat. Crews often ended up jettisoning their missiles without even attempting attacks, rather than risk bringing armed weapons back to base for landing. Post-war analysis conducted by the Joint Army-Navy Assessment Committee concluded that the bat's effectiveness in actual combat conditions was mediocre at best. The weapon performed beautifully during testing against isolated targets in open water under controlled conditions, but struggled mightily in the complex, messy environment of real warfare. Radar clutter from islands and coastlines, interference from weather systems, and the primitive nature of 1940s electronics all degraded performance significantly. Yet even this limited success absolutely terrified Japanese naval personnel who encountered it. They had no countermeasures to employ, no understanding of the underlying technology attacking them, and no effective defense they could mount. Ships struck by bat missiles reported being hit from nowhere by weapons that gave no warning whatsoever. The psychological impact far exceeded whatever physical damage the missiles inflicted. The bat missile program symbolized the fundamental philosophical difference between how America and Japan approached warfare. America could afford to spend millions of dollars developing a weapon that ultimately sank only 3 small vessels, because the investment advanced technology and understanding that would define future conflicts for decades to come. Japan, meanwhile, couldn't even conceive of such weapons in the first place, much less develop countermeasures or defenses against them. American production methods allowed for rapid iteration and continuous improvement. When early bat missiles showed problems with humidity affecting their electronics, engineers quickly developed better sealing methods and implemented them across the entire production line. When radar seekers kept locking onto land masses instead of ships, modifications to what we'd now call software improved target discrimination. Each problem identified in combat led to rapid solutions that were immediately incorporated into new production batches. Japanese forces, by stark contrast, struggled just to maintain the equipment they already had. By 1945, fuel shortages meant ships often couldn't even leave port. Ammunition quality had degraded terribly due to shortages of critical materials. The few radar sets that existed frequently failed due to lack of replacement parts and trained technicians who could repair them. The technological gap wasn't just about having advanced weapons, but about basic industrial capacity and the ability to sustain military operations. Behind the Bat missile's development were thousands of American scientists and engineers who approached warfare as fundamentally an engineering problem that could be solved through application of scientific method and industrial production. Dr. Hugh Dryden, who led the National Bureau of Standards team, viewed the entire project through the lens of aerodynamics and control theory rather than military strategy. His team included specialists in fields that barely existed before the war began, experts in servo mechanisms and analog computing and radar technology. On the Japanese side, naval officers trained in traditional concepts of warfare found themselves facing weapons that completely negated their lifetime of training and preparation. The emphasis on spiritual strength, warrior courage, and aggressive offensive tactics meant absolutely nothing when fighting against weapons that killed from beyond visual range. The samurai tradition that deeply informed Japanese military culture had no answer whatsoever to American industrial warfare. The concepts of honor and personal combat that had sustained Japanese warriors for centuries simply didn't apply when death came from missiles guided by radar and electronics. The Bat missile attacks created a unique kind of psychological trauma among Japanese sailors who survived them. Death in battle they understood and accepted as part of a warrior's fate. But death from invisible thinking weapons struck at fundamental beliefs about warfare and what it meant to be a soldier. Survivors reported overwhelming feelings of confusion, helplessness, and a terrible sense that they were facing something beyond the bounds of normal combat. While the Bat represented the ultimate expression of automated warfare, Japan responded with the exact opposite extreme in the form of the kamikaze. Where America removed pilots from danger through superior technology, Japan turned pilots into human-guided missiles through ideology and indoctrination. This contrast illustrated perfectly the different civilizational approaches these two nations took toward warfare. The kamikaze program, initiated by Vice Admiral Takejiro Onishi, explicitly aimed to counter American technological superiority through what they called spiritual superiority. Onishi reportedly stated that Japan could not match American science and industry, but they possessed what Americans lacked: warriors willing to sacrifice themselves completely. The parallel development of these opposite approaches, mechanical precision versus human sacrifice, technological innovation versus ideological fervor, defined the final brutal phase of the Pacific War. American sailors facing kamikaze attacks experienced a terror similar to what Japanese sailors felt when confronted with guided weapons. Death arriving too fast to effectively counter, from attackers who couldn't be deterred by defensive fire because they welcomed death. But where the Bat represented the future of warfare, the path that would be followed for decades to come, kamikaze attacks were the last desperate gasp of a martial tradition being crushed under the weight of industrial modernity. The Bat missile operated within the larger context of America's systematic campaign to strangle Japan through overwhelming technological superiority applied across multiple domains. Operation Starvation, conducted by B-29 bombers dropping magnetic and acoustic mines in shipping channels, had by April 1945 virtually eliminated Japanese coastal shipping. Submarine warfare had destroyed most long-range merchant vessels, cutting the home islands off from resources in conquered territories. The Bat missile added yet another layer to this comprehensive interdiction campaign. While the Bat's direct contribution in terms of ships actually sunk was minimal, its psychological impact multiplied the effectiveness of all other American operations. Japanese captains became reluctant to put to sea even in areas where no Bat-equipped squadrons actually operated. The mere possibility of guided weapon attack added to the paralysis that was gripping Japanese maritime operations. American planners deliberately worked to enhance this psychological warfare effect. Intelligence officers ensured that Japanese forces learned about the Bat missile through various channels. Documents describing the weapon were allowed to fall into enemy hands. Radio broadcasts discussed thinking bombs in terms designed to spread fear. Survivors of attacks were allowed to escape so they could spread stories through the fleet about weapons that struck from empty skies. The goal wasn't just to sink ships, but to make Japanese commanders afraid to use the ships they still had. The Bat missile represented a remarkable technological achievement, but it also revealed the severe limitations of 1940s electronics and computing. The analog computer that guided each missile consisted of vacuum tubes prone to failure from vibration and heat, mechanical servos that required precise calibration and could be thrown off by combat damage, and radar systems that were easily confused by environmental factors like rain or sea clutter. Success required near-perfect conditions, clear weather, isolated targets in open water, and electronics that functioned properly throughout the entire flight. These limitations help explain why the combat record was so modest compared to the revolutionary nature of the technology. Of approximately 100 Bat missiles actually fired in combat situations, only a handful achieved hits on their intended targets. The weapon worked best against stationary or slow-moving targets in open water, well away from land masses that could confuse the radar seeker. Moving targets in congested waters near coastlines or attacks conducted in poor weather often resulted in complete misses. Yet even this limited success proved the fundamental concept was sound. Every subsequent guided missile program built directly on lessons learned from the Bat. Engineers identified critical technologies that needed improvement for future systems. Better radar discrimination capability, more reliable electronics that could withstand harsh environments, improved servo mechanisms that responded faster and more accurately. The Bat was less a finished weapon system ready for mass deployment than a proof of concept demonstrating that automated warfare was actually possible. The last Bat missile attack of the war occurred on August 13, 1945, just days before Japan would surrender unconditionally. VPB-109, flying from newly captured bases on Okinawa, launched 2 missiles at what the crew believed were Japanese vessels. Both weapons missed their targets completely, a fitting end in some ways to a weapon that promised revolutionary capabilities but delivered mixed results. By the time the war ended, approximately 420 Bat missiles had been deployed to the Pacific Theater, with only about 100 actually fired in combat. The remainder were shipped back to the United States, where post-war testing continued until 1948. These peacetime tests yielded valuable data but demonstrated continued reliability problems, leading the Navy to remove the Bat from active inventory by the early 1950s. Yet the Bat's failure as a practical weapon system masked its enormous success as a technological demonstrator and proof of concept. Every American guided missile that followed, from the Sidewinder air-to-air missile to the Tomahawk cruise missile, incorporated fundamental lessons learned from the Bat program. The engineers and scientists who worked on developing the Bat went on to lead development of Cold War missile systems that would define superpower confrontation for decades. Dr. Hugh Dryden took the knowledge gained from the Bat project into his work at NASA, where automated guidance systems would be essential for space exploration. The technological lineage is direct and undeniable. For the Japanese forces that encountered Bat missiles in combat, the psychological impact went far beyond the limited physical damage inflicted. Captured documents and post-war interviews reveal that many Japanese personnel simply couldn't comprehend what was attacking them. Some thought the Americans had developed death rays, a concept from science fiction that seemed more plausible than the reality of radar-guided missiles. Others speculated about remote-controlled aircraft so small they couldn't be seen. The inability to understand the nature of the threat made developing effective countermeasures essentially impossible. Post-war interviews with Japanese naval officers who survived the war revealed the deep psychological wounds caused by facing automated weapons they couldn't comprehend. These were men who understood being outproduced, outgunned, and outnumbered. They could accept defeat by an enemy with more ships, more planes, more men. But being killed by thinking machines struck at fundamental assumptions about what warfare meant and how battles should be fought. Several officers described the experience as facing not just superior technology, but an entirely different conception of what war itself was supposed to be. The Japanese Navy's Technical Bureau did attempt to analyze the threat and develop countermeasures, but without captured examples to study or any understanding of the underlying technology, their efforts went nowhere productive. Proposals for countermeasures ranged from the practical, like using smoke screens to confuse radar systems, to the desperate and bizarre, like deploying suicide swimmers to intercept incoming missiles. None of these proposals were actually implemented before the war ended, and most would have been completely ineffective even if they had been tried. The BAT missile's technological DNA runs through every modern precision weapon system in use today. The fundamental concept of fire-and-forget engagement, where the weapon autonomously selects and tracks its target after launch, originated with the BAT. Modern anti-ship missiles like the Harpoon and Exocet are direct descendants, incorporating the same basic concept but with vastly improved technology. The ethical questions raised by the BAT about automated killing, about removing human decision-making from the application of lethal force, about the psychological impact of fighting against invisible enemies, all of these issues presaged modern debates about drone warfare and autonomous weapon systems that continue today. The BAT was the first weapon in human history to kill without human guidance after the moment of launch, crossing a threshold that military ethicists are still grappling with decades later. When does automation in warfare go too far? Who bears moral responsibility when a machine makes the decision to kill? These questions first arose with the BAT missile in 1945 and remain unanswered in any definitive way. For the United States Navy, the BAT program provided crucial lessons about guided weapon development that would save enormous amounts of time and money in future programs. The critical importance of reliable electronics that could function in harsh military environments, the need for effective target discrimination so weapons could tell friend from foe, the value of operational simplicity so ordinary servicemen could employ complex weapons. All of these lessons emerged from analyzing the BAT's mixed combat record. These insights informed every subsequent missile program, preventing engineers from repeating mistakes and allowing them to focus on genuinely unsolved problems. Looking at the raw statistics, the BAT missile program reveals both impressive achievement and significant limitations. Total production reached approximately 3,000 units, with 420 deployed operationally to combat zones. About 100 were actually fired at enemy targets, resulting in 3 confirmed ships sunk, all small vessels, and 1 escort vessel damaged. The program cost $12 million in 1945 currency, and development time from initial concept to combat deployment was just 36 months. These numbers show a weapon that achieved very limited tactical success while holding enormous strategic importance for the future. The 3 ships actually sunk mattered far less than the technological path opened toward precision warfare and automated weapons. The BAT proved that guided weapons were not just theoretically possible, but practically achievable and potentially decisive in future conflicts. The ASM-N-2 BAT missile stands as a genuine watershed moment in military history, representing the first autonomous weapon to kill in combat without human control after the moment of launch. Its modest combat record of 3 small vessels sunk and 1 ship damaged belies its enormous historical significance as the direct ancestor of every smart weapon that has followed in the 80 years since. For the Japanese sailors who faced these weapons in the final months of the war, the BAT represented incomprehensible technology that negated everything they understood about how naval warfare was supposed to work. Death arrived from empty skies, delivered by machines that could see in darkness with radar and think faster than any human with their analog computers. These men were the first warriors in all of human history to face truly automated weapons, and their confusion and terror marked humanity's entry into an age where wars would be fought as much by algorithms and electronics as by soldiers and sailors. The BAT missile didn't win the Pacific War by itself. That victory came from the cumulative effect of overwhelming American industrial production, superior logistics and supply chains, better intelligence and code breaking, and ultimately the atomic bombs dropped on Hiroshima and Nagasaki. But the bat showed what the future of warfare would look like. Precision rather than mass, automation rather than human courage, technological superiority rather than warrior spirit. Every guided missile, every smart bomb, every armed drone flying today traces its technological lineage directly back to those first primitive radar-guided weapons released over the Pacific in 1945. Today, as heated debates rage about autonomous weapons systems and the ethics of automated warfare, about killer robots and the role of artificial intelligence in military applications, we're still fundamentally grappling with questions first raised by the Bat missile 8 decades ago. When machines can select and engage targets without human intervention after initial launch, who bears moral responsibility for the deaths that result? How do warriors and soldiers maintain meaning and purpose when technology increasingly negates human skill and courage? What happens to the nature of warfare itself when killing becomes a mathematical calculation rather than a personal act? These profound questions, first posed by an 1,800-pound glide bomb with vacuum tube guidance and analog computing, remain largely unanswered even today. The Bat missile achieved very little in terms of immediate military impact measured in enemy ships actually destroyed. But it opened a door that can never be closed again. The age of thinking weapons, of automated warfare, of machines making kill decisions had begun, and the nature of human conflict would never be the same. The Japanese sailors who died without ever seeing their attackers, without understanding what kind of weapon had killed them, were the first casualties of this new age of automated warfare. Their confusion and helplessness in the face of technology they couldn't comprehend presaged the experience of every soldier since who has faced precision-guided weapons and wondered how to fight an enemy you can't see, can't hear, can't predict. They discovered, in the most terrible way imaginable, that the future of war would belong not to the bravest warriors or the most skilled tacticians, but to whoever could field the smartest weapons. The Bat missile flew into the history books carrying more than just 1,000 pounds of high explosives in its warhead. It carried with it the end of one entire age of warfare and the beginning of another, an age that we're still living in today, still trying to understand, still struggling to control through international law and ethical frameworks. In that sense, the humble Bat missile, with its modest combat record of 3 small ships sunk but its magnificent implications for the future, may well have been one of the most important weapons developed during World War II, despite the fact that almost nobody remembers it today. The men who designed it, the crews who flew the missions, the Japanese sailors who died beneath its impact, all of them participated in a moment of transition that would reshape warfare for generations to come. The thinking bomb had arrived, and nothing would ever be quite the same again.